You're typing a text message, and before you even finish your sentence, your keyboard suggests the exact word you were about to use. Your phone is using basic probability. By looking at the few words you just typed and remembering your personal history of previous text messages, it makes a mathematical guess about what you will probably say next. Modern artificial intelligence runs on that exact same mathematical guessing game, but scaled up to an extreme degree. Instead of a small history of your personal texts, these new systems have ingested massive, encyclopedic databases containing centuries of human knowledge. They've also read the entirety of casual human conversation. By absorbing years of chaotic internet forums and social media threads, the software learns the subtle nuances, slang, and tone of how people actually speak to one another. We call these massive software systems large language models, or LLMs. They are not thinking brains. They don't have thoughts or feelings. An LLM is simply a massive mathematical engine, rapidly calculating the single most likely piece of a word to type next, based on the patterns of the entire internet. To understand how it does this, we have to unlearn how we read. Computers don't see letters, and they don't see words. They only process math. When you type a prompt into an AI, the system immediately chops your sentence into smaller fragments called tokens. A token might be a single syllable, a short word, or a piece of punctuation. These tokens are then translated into numbers. Once your sentence is turned into a string of numbers, the machine can begin to calculate. Older software used to guess the next word by only looking at the one immediately before it. Modern LLMs use a technique called attention. Attention is a mathematical formula that connects all these pieces together. It allows the model to scan an entire paragraph, identifying how a word at the beginning of your prompt relates to a word at the end. By weighing the context of every token, the model assigns probability scores to millions of potential responses, sorting until it finds the absolute best next token. This combination of math and context allows the machine to reproduce the structure of human conversation without ever needing to understand the meaning behind the words. To get to that level of fluency, the model goes through a pre-training phase. It sits in a server and absorbs raw data from the web for months, learning the basic rules of grammar and logic. After the initial training, human reviewers manually rank the AI's responses to ensure they are helpful and safe. This alignment process uses those scores to adjust the internal math until the model favors the answers humans prefer. Because language is the foundation for almost all human knowledge, a machine that predicts text patterns is incredibly versatile. It can translate languages, draft historical essays, and even write complex computer code, all by guessing the next best token. Since the model only cares about probability, it can confidently invent fake facts. If the math determines that a specific name or date fits the sentence structure well, the AI will output it as truth, even if it's entirely fabricated. This tendency to hallucinate is a side effect of prioritizing patterns over reality. Generating these probabilities also carries a heavy physical cost. Running billions of mathematical equations for every single word requires expansive, climate-controlled data centers and massive amounts of electricity. The ability to generate any pattern makes large language models incredibly flexible, but it also makes them unreliable for strict factual accuracy and expensive to operate. Because of that extreme size and cost, the tech industry is actively shifting away from these massive generalized systems. Engineers are shrinking these models through distillation, compressing the core logic of a massive network into a streamlined node for specific tasks. These smaller models run fast, operating locally on your smartphone without needing a distant data center. Because these models generate computer code, they can act as a bridge to your other apps. Give a verbal command, and the AI generates instructions for a calendar or travel site to execute a task for you, like reserving a flight. Small, highly specialized agents will work behind the scenes to actively complete your tasks. When you use modern AI to answer a question, you are interacting with billions of calculations happening in a fraction of a second. There is no conscious mind inside your screen. It is a massive, high-speed game of fill in the blank that is only just beginning to evolve.